Occasionally on homeworks, even on tests, you'll see something like this. It's because I removed the problem and I didn't want to change my numbering scheme. So you get a free one once in a while. So for 26 and 27, we're looking at composition of functions. This can be a hard concept to understand, but here are the mechanics of it. F composed with G, rewrite as F is the outside function, G, in the case of X, is the inside function. Right? So now look up here and see what G is, and you can replace that. 4x minus 2. Alright? So F is the outside function, G is the inside function. The first one is the outside, the second one is the inside. Once you've written it like that, go look at your function definitions and replace the inside function. Now, you treat this as though it's a typical function notation, meaning that whatever's in here gets substituted for the x's in the function. So I would have 3, I'm going to put this in red now. Now, instead of that x, I have to put 4x minus 2, happens to be squared. Then I had a negative 2, here's another x. So again, I go 4x minus 2, and then plus 7. Then just work out the arithmetic. That is F composed with G. Remember, you have to FOIL this and combine similar terms. The importance is to get this idea of outside-inside functions and then get that replacement. Now when you come to something like G composed with G, at first that doesn't look like it makes any sense, but you can do exactly the same thing. This G is the outside function, G is the inside function. Alright, fine. Now I go back up and find out what G is because I want to replace this. It's 4x minus 2. So this 4x minus 2 is going to replace every x in G. There only happens to be one. So here's how it would look. You'd have the 4. Now you come to an x. So you replace it by 4x minus 2. And then you have a minus 2. Now you can carry out your arithmetic. For example, you might want to multiply through by the 4, distribute the 4 through the parentheses. I've got 16x minus 8 minus 2. Combine similar terms. 16x minus 10. Alright. Writing 16x minus 10 on your homework gives you a credit of, well, it's going to look like this, minus 1. It's important that you show the work. I really don't care what you get at the final answer. I want to know that you know how to do the problem. These questions are on the symmetry of various functions. There's two ways to determine symmetry, but I would like you to use algebra. How do you use algebra to determine if a function is even, odd, or neither? Well, you substitute minus x for x. You have to use parentheses and go through the whole formula. So in this case, there's a minus, that's a negative sign, to the 4th plus 3 times negative x squared plus 6. So you substitute it in. Try to clean that up a little bit. Minus x goes wherever these x's are. Using parentheses, then work it out. If after you work it out, if you get back the original function, so if f of minus x doesn't look any different from f of x, then the function is even. If you put that negative x in and you get out a negative of everything you started with, that function is odd. On the other hand, if you don't get those answers, the function is neither. It's neither even nor odd. Let's take as example the first two terms here. Say the 6 wasn't on here. Okay, so you would put a negative x in, then you would go 5 minus x cubed plus 3 times negative x. Okay, if you take a number, if you take minus x cubed, you would have minus x times minus x times minus x, which would give me I'd have these two negative signs go away, but this remains. So I have a negative x cubed multiplying the 5. This would give me minus 5x cubed. Okay, 3 times the negative x gives me minus 3x. Well, that is the negative of everything I started with. In that case, it would be odd. You will get different results when you consider that there's a constant at the end of that. When we talk about symmetry in math, we usually mean with respect to the x-axis or the y-axis. So we generally look for symmetry about vertical symmetry. We want to see if the function is exact. Whoops. Alright. Let me draw some of that in there. Okay. If the function is exactly the same, say it does like this on this side, and it does exactly the same on the other side, then we say this is an even function. Alright. If it starts out here, say it goes like that on this side, but on this side it does the opposite, that's an odd function. Alright. And that's mainly what we look at in math. When it comes to the physical world, like crystals, we look for symmetry with respect to any line that we can find. That means we could draw a line anywhere. In this case, I'm going to draw a line right through here. You can see if I folded that snowflake over, it would lie on top of itself. So what it's doing on this side of the red line over here, whoops, I still got that line. I guess I like to keep holding that thing. It's the same over here. So it's symmetric about that line. Then you look for other lines you could draw on there. Well, for example, I could go right between these, and if I looked, I would have the exact same thing on both sides of this particular line. So you keep drawing lines on there to see how much symmetry you can get. Actually, 6 is the magic number for a snowflake. It has to do with how the crystal of the water crystals are, and how the fact that it freezes and reforms as it grows. Here is another crystal, but it's not a snowflake. Okay. The point of this one is, first of all, you're supposed to ignore those little fuzzy things, the photographic imperfections, and try to find lines on this crystal, even though it's not in a straight up and down axis, but find lines through this that if you drew the line, you would have exactly the same thing on either side. Okay, there's 2 of them for this example. Now here is the difference quotient. The difference quotient has a lot of algebra in it, and that's why it's given here. Also, for anyone planning to go on into calculus, the first 3/4 of the semester of the first of calculus 1 is computing difference quotients. But it's not just for people who are going to calculus. It really helps you learn algebra. Basically, all you have to do is remember what function evaluation means and just follow the formula. I will never expect you to memorize the difference quotient formula. I will always give it to you, and it's given to you right here, so you don't have to write it. This is it. Okay, what does it mean? I'm going to look at this one right here. First case. All right. To compute the difference quotient, I make a fraction, and the denominator is an h. All right, easy enough. Every place that there's an x for this first term, I put x plus h. That's what function evaluation is. If I had a 2 there, that means every place there was an x, I would put a 2. Here, you're going to put x plus h. So I put a 3 using parentheses, x plus h plus 6. Okay, that's the first term. Now here's a little bit of a trick. It says minus the function. Well, the function has several pieces, so again, I better put it in parentheses. Now I'm going to erase that so I have some room to work here. Okay. The next step is just to work this out using algebra, which you know. You take the 3 and you distribute it through that parentheses. I get 3x, and I get 3h plus 6. Now, I'm subtracting, so the negative sign has to go to both terms, right? Giving me minus 3x minus 6. This is all divided by h. Now look back again, continuing this is just arithmetic. Now you're going to subtract off terms that are the same, or cancel them out rather. Let's see. I want the red pen. Okay, so here's a minus 3x goes against the 3x. The plus 6, minus 6. So when I'm done with all that, in this case I end up with 3x h over h. The h's can cancel, and the answer is 3. This next one is a little trickier, but it's the same procedure. X plus h squared minus 4, subtracting the original function, all divided by h. Okay, what do I have to do with x plus h squared? I have to FOIL that. So I've got 3 x squared plus 2xh. You might have to work out the terms if you can't see that right off the bat. Minus 4. Now I'm subtracting, so the negative sign goes there onto the 3x. It also goes here, so that minus 4 becomes a plus 4. All over h. Right. You won't get a simple answer when you're done. You won't get a numerical answer when you're done with this one. There will still be h's in the equation, and that's perfectly acceptable. So I take your 3, distribute it, subtract off the terms that you can, and simplify. In this case, we're looking at the transformations of a graph. So some people have a problem with the directions here, so I'll try to explain that. You're given the graph. This is your function. Just take it as this is the form that you're given. And this is your f of x. Okay. Now if you had a negative sign, negative f of x would mean every value that's positive becomes negative. So you can see what you have up there at about 4 becomes, so this thing would kind of go like this, right? You'd have to look at the values, you could figure it out. I'm just sketching. This column you're supposed to explain what happens. When you put the negative sign, you reflect it. That's a reflection. Reflect about the x-axis. You see, it's as though I took the function and just pulled it down. Now, you still have that negative sign here. Now you've got x minus 2. All right? This means shift horizontally because you're bothering the x, so to speak. But it's counterintuitive. If you put a minus 2 here, it means go to the right. If you had a plus 2, it means go to the left. So you would take that graph and just move it over to where it needs to go. And whoops, I kind of made a mistake there, but you can go ahead and figure out from the values. Now, in this case, you've got the negative sign, which we've already accomplished here. You've got the minus 2 taken care of here. Now you're going to add 3. Plus 3 on the end of a function is a vertical translation. You take the whole graph and you move it up 3.